Welcome. In this video, we're going to talk about the Pythagorean theorem and how we can use it to calculate distance on the Cartesian plane. So the Pythagorean theorem, as you probably know, says that if you have a triangle with a right angle in one corner, then you can figure out how long the longest side is opposite that corner based on how long the other two sides are. And the equation for that is a squared plus b squared equals c squared. So if you multiply the length of a times itself and you add the length of b times itself, you get the length of c times itself. So let's say a equals 3, b is 4. How long is c? So we plug in the values. A equals 3, b equals 4, and we don't know what c is. And we get 3 squared plus 4 squared equals c squared. So now we know that 9 plus 16 is c squared. And if we add 9 and 16, we get 25 equals c squared. So c must equal 5. And this works pretty much for any triangle as long as it has a right angle. So how does this help us when we're on the Cartesian plane? Well, let's say we have a Cartesian plane like this. So 0, 0 is right here. And we want to know how far it is to some point over here. And we don't know. We want to know exactly how far it is between those 2 points. Well, we can use Pythagoras because we know that this makes a right angle. So this is going to be our A, this is going to be our B, and opposite the right angle is going to be C. We can measure A by counting 1, 2, 3, 4, 5, up. We can measure B by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we use our Pythagorean theorem, then we get 5 squared plus 10 squared equals c squared. We get 25 plus 100 equals c squared. So we know that 125 equals c squared. And if we take the square root of 125, we'll get c. And that's about 11.18. So the distance from here all the way up to there is about 11.18. Well, that's all very nice, you say, but say I want to have the distance between 2 points that are not at the origin. So I want to have the distance between, say, this point here and some point over here. I can still use the same formula. I draw my lines between the 2 points because I know that this is going to be a right angle. So once again, I can just say A is a short side, B is a short side, and opposite the right angle is C. And I can count my steps. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know that a squared plus b squared equals c squared. 49 plus 100 equals c squared. 149 equals c squared. So I take the square root of both sides, and I get about 12.2. So now you're saying to yourself, that's great, but what if I have 2 points that are really far away, like 500 and 1,000, and I don't really want to count steps, all of them? Well, luckily we can create a formula to do that for us. So say we have a point over here, and it's at 5, 13. So the x value is 5 and the y value is 13. And my second point is at 17, 4. So again, I want to know what is the distance between those 2 points. And instead of having to count steps, you can just look at the numbers and subtract them. So if I know that the x value of the point over here is 17, and the x value of my upper point over here is 5, then I know that the distance between them is 17 minus 5. Similarly, if I know that the y value of my bottom point there is 4, and the y value of the top one is 13, then I can just take 13 minus 4, and I know that this distance here is 9. So my a value is going to be 9. My b value is going to be 12. And my c value, well, I don't know what that is yet. But I do have a formula for it because I know that a squared plus b squared equals c squared. So I plug in my 9, I plug in my 12, and I can find out what c is. 81 plus 144 equals c squared. So I add these together and I get 225 equals c squared. So 15 equals c. So again, all I had to do was find the distance between the 2 points for the x value, the distance between the 2 y's for the other side. I squared them, I added them together, and then I took the square root of both sides to give me my answer. So we can come up with a formula for this now. So going back to my original drawing, I know that a is going to be the difference between the y values. So a is going to be y2 minus y1. 13 minus 4. B is going to be x2 minus x1. 17 minus 5. And C, we don't know yet. But because I know that C equals a squared plus b squared, I can just plug in that for a and that for b, and I'll be able to calculate any distance between any 2 points at all. So plugging in this for A and this for B, I get c squared equals y2 minus y1 squared plus x2 minus x1 squared. And this right here is our distance formula. It will work for any 2 points on any Cartesian plane. So to conclude, to get the distance formula from Pythagoras, we start with a squared plus b squared equals c squared. We take the square root of both sides, and we get c, which is the distance between the 2 points, equals the square root of a squared plus b squared. In order to do that with any 2 points on a Cartesian plane, we take the x value of the first point, subtract the x value of the other point, square that. That gives us one length of our side. Then we do the same thing for the y values, which gives y2 minus y1 is the difference between their y values is the length of the other side. If we square those, add them up, take the square root of the whole thing, we'll end up with the hypotenuse, or the distance between the 2 points.